I want to talk about the energy associated with nuclear fission and nuclear fusion reactions. First of all, let's compare the energy of nuclear reactions to that of chemical reactions. The black here is a normal chemical reaction, maybe something catches on fire or a conventional bomb goes off. We're looking here at a reaction progress diagram. The y-axis represents energy. So the reactants of, we start here, we first have to add energy to get a reaction to happen. So going from where the reactants start to the top of the hill is the activation energy. And after we reach the top of the hill to the transition state, then you start getting energy out. And in an exothermic reaction, the products are going to be lower in energy than the reactants. So the energy comes out from the chemicals, essentially, and we feel heat, yada, yada. But the main point here is that a chemical reaction where only electrons are moving around, the nucleus isn't touched, in a chemical reaction, you have a lot less energy that you need to put in and a lot less energy than you need to get out compared to a fission reaction. So you need more energy to make a fission reaction start, but the products are much lower in energy than the reactants, and you get a lot more energy out. So, this is why nuclear power plants are so powerful. But yeah, the fission reactions are those that happen in nuclear power plants and earlier atomic bombs with uranium and plutonium. So these are the bombs that were used at the end of World War II in 1945 were fission nuclear weapons. But then, after World War II, they developed hydrogen bombs. So here, in the hydrogen bomb, helium is made when hydrogens fuse together. Two hydrogens combine or fuse to make helium. And here's the thing. Helium is a lot more stable than hydrogen. So even though we have to add a lot more energy to get the reaction, the fusion reaction to start happening, we get a whole lot more energy out. So if fission reactions make chemical reactions look wimpy, then fusion reactions make fission reactions look really, really weak. But yeah, the activation energy for fusion reactions is really high. I've heard that they actually needed to use a small fission nuclear weapon to go off just to trigger the hydrogen bomb to start its fusion reaction. They basically put a weaker fission bomb inside the hydrogen fusion bomb. And this fusion reaction of hydrogen to helium is what happens in the sun. It's where the sun gets its energy that it radiates out. And I wanna sing a pop song for you. I kind of have to. It's by They Might Be Giants, and it goes like this. The sun is a mass of incandescent gas, a gigantic nuclear furnace, where hydrogen is built into helium at a temperature of millions of degrees. It would be really exciting if we could harness the power of hydrogen fusion and have nuclear plants that were based on the reaction of hydrogen combining to helium. The problem, the key hurdle to get through is controlling that reaction, not letting it rage out of control, have all your hydrogen explode at once and blow up a whole state. So that would be a great, safer, cleaner, more renewable energy source than what we have going on now. Every water molecule has two hydrogens on it. So that's maybe in our lifetimes that would be a huge game changer.